Today we are going to learn about in statistics and numerical methods. In second unit we are going to discuss about design of experiment. In the design of experiment, which is completely used on the ANOVA table. So first thing we are going to learn about completely randomized design. So our aim is to learn about completely randomized design. It's based by this is our topic. Today we are going to cover this topic alone. And then so myself I am Sriram, Assistant Professor, Department of Mathematics from St. Joseph Institute of Technology. Now we may move into the topic first. In design of experiments, we are going to see first analysis of variance, that is ANOVA. So ANOVA means it's a statistical method. Used to test the difference between more than two means. So which is the basic definition of ANOVA. ANOVA is one of the statistical methods to test the difference between more than two means. So which is called as analysis of variance. In short, we are saying that it is ANOVA. So ANOVA, it is used, the uses of ANOVA. Uses of ANOVA. It is used to test the homogeneity of the means. It is on one side, or in second, it is used to test the linearity of the regression lines. So these are the two uses of ANOVA table, right? So there will be assumptions are there. So first we are going to see what are the assumptions in ANOVA. Assumptions in ANOVA. Assumptions in ANOVA. The sample observations are independent. First one, sample observations are independent. Second, environmental effects are additive in nature. Environmental effects are additive in nature. Okay, so and then one of these two are the assumptions in the ANOVA table, and then the basic principles. One of the important things to understand, that is basic principles of design of experiment. Basic principles of design of experiment. There are three types are there. First one, randomization. Second one, replication. Third one, local control. So these three are the very important basic principles of design of experiments. Okay, so now next we may move on into the topic, that is completely randomized design. Completely randomized design or we can simply call it as one-way classification. One-way classification. So it is used, that is completely randomized design. The treatments are given in the experimental units by a procedure of random allocation. So that means what? The treatments are given in the experimental units by a procedure of random allocation. Right? So, hello everyone. So once again we are in the topic of completely randomized design. Completely randomized design. So here we are going to see about the basics, that is how we are going to construct the completely randomized design first, then we are entering into the problem, right? So the first one, what are the steps needed for completely randomized design? This is already I said that this will be an CRD problem, or else we are calling it as one-way classification. One-way classification, right? CRD or one-way classification, right? So working procedure, right? So we are going to write it as working procedure for CRD. Okay, working procedure for CRD. First one, if you are looking out a problem in CRD, first we need to write out the null hypothesis and H1. That is, H1 is nothing but the alternative. So null hypothesis and alternative hypothesis. Whenever we are going to write H0 and H1, H0 is null hypothesis. So we have to say, there will be a set of samples will be given. In the samples, we are going to say there is no significance difference between the samples, between the samples. Then H1, there is a significant difference between the samples. So first thing, whenever you are starting with the problem, so you have to state H0 and H1. After that we move on to the steps. The first, these are the basic things. There will be two types of problems we are going to see. The problems are, one is in the row wise and another one is the column wise. Okay, there will be two types of problems, so row wise and column wise. Row wise and column wise. Okay, here we are going to discuss the problems in the row wise. Here the problem we are going to discuss in the column wise. Right. So first step 1, we need to find out the total. We are going to use T and then number of observations as capital N. The same case here, step 1, we are going to see total as T, number of observations equal to N. Step 2 is correction factor. Correction factor CF equal to T square by N. The same case here, step 2, CF as T square by N. Step 3, here the TSS nothing but total sum square. So the total sum square is calculated as x1 square, x2 square, up to how many number of elements are there, you have to square all the numbers here, plus xn square, subtract with the CF value. The same way here, step 3, the TSS here, x1 square plus x2 square plus up to etc xn square minus CF. Step 4, here we are going to call row sum square. So here the row sum square is calculated as summation r1 square by n1, summation r2 square by n2, up to how many rows are there you have to do, n square by n minus CF. The same way, the step 4, summation c1 square by n1 plus summation c2 square by n2 up to number of columns. How many number of columns is there? We have to do it for things minus CF. So this is the way, this is our CSS value. CSS and RSS are these things. The step 5, here the step 5 the same thing. So ESS is calculated by TSS minus RSS. So in the case of column wise, TSS, that is ESS, is calculated by TSS minus CSS. So with this, these are the basic things to calculate for any kind of, that is a row wise problem or column wise problem, we have to calculate. Now we move on to the ANOVA table. In ANOVA, table, there will be first one, source of variation, second one, degree of freedom, third one, sum of squares, fourth one, mean sum squares, the last one, F cap. So if you are going to write it for an ANOVA table, so these are the basic things. So this is common for both row wise and column wise. So first one, between, this is if you are going to consider for row wise, between rows you have to write, or if you are going to write it for column wise, between columns you have to write. Alright, if we are going to calculate for degree of freedom, r minus 1 you have to use, or if you are going for a column wise you have to use c minus 1. Right? This is for finding degree of freedom. and then sum of squares RSS value, or if it is a column CSS value, you need to calculate, right? So mean sum square is calculated for row wise. MSR equal to RSS by R minus 1, or else MSE, the MSC is calculated by CSS by C minus 1. So this is the basic rule. Then the for error value. So error has two kind of formulas. The first one is n minus r, this is for row wise, and then n minus c for column wise. So here ESS is counted. So MSE is ESS by n minus r, or ESS by n minus c. This is for column wise and this is for row wise. So finally, which one will be greater? You have put it in the upper sign. That is, if I am going for fcal value is calculated as if the value, these two kinds are there. If SR is greater than MSE, then fcal R equal to MSR by MSE. Okay, if MSR is less than MSE, so that fcal R equal to MSE by MSR. So this is the formula for doing in the row wise. If you are going to calculate for column wise, if MSC is greater than MSE, so fcal of C equal to MSC by MSE, or else fcal of C equal to MSE by MSC. Right, so this is the way we have to calculate. With the help of this table is over. After that, you need to calculate the table value. F table, that is, F table is calculated as the first thing. You have to read the question properly. If the question contains LOS value, LOS nothing but level of significance. Is given any value, the level of significance value lies as 1%, 5%, or 10%. Sometimes the problem which but not hold the level of significance, if the level of significance is absent in for any problem, that means you have to use the 5%. You have to use the 5%, so or else 0.05. So F 0.05 of nu1 comma nu2. Right, nu1 is nothing but greatest. Nu1 is founded by greatest values degree of freedom. Okay, degree of freedom. So that you have to find out the value here. Okay, greatest value. With the help of that, when you are going to calculate the fcal value, that is f tab value, f tab of C or f tab of R, which is under 0.05 or else 1% or 10%, that value you will get that. We are going to compare these two values, that is fcal and we are going to compare fcal of row or fcal row with f tab R. The same page, this is for row wise. In column wise, fcal C compare with f tab R, f tab C. So if it is less than, in these two cases we are going to accept H not here, the same case here, accept the H naught, right? So accept the H. If not, if the both cases are fails, then we are going to reject the H naught or accept the H1, or else, or in row wise, F cal R is greater than F tab R, F cal C is greater than F tab C, we are going to reject, okay, we are going to accept the H1. Both cases contain the same answer. So this is the way we are finding out for all the things whatever we have discussed here. So this is the way we need to find out. By this way we are finding out the answers. Right, this is the common working procedure of CRD for both cases row wise and column wise. Right. So we will see two kind of problems in row wise and column wise by the next videos. Thank you.